record. Okay, so let's go to Pearson. The review has 40 questions. The first question, factor by using either the difference of two squares or the perfect square trinomial formula. So x to the power fourth. Let me quickly copy paste. I'm gonna work that problem on my OneNote. This is a binomial, right? The binomial is more complicated than the examples. So x to the power fourth is a binomial. Remember, when we need to factor binomial, we check GCF first, right? Obviously, the binomial here, GCF is 1. There's nothing we can factor out because this term only has x and this term has no x. And then binomial, we would consider if the binomial a difference of two squares. The question makes it easier because it says use the formula. So we are going to figure out a way to use this formula to factor this binomial. So x to the power fourth is x times x times x times x, and we can let these two x together, these two x's together make x squared, and then we can make these two x's another x squared. So x to the power fourth is x squared to the power 2, right? So we can write the first term as x squared to the power 2. And 625, you guys remember, let me pull the note. I want you to memorize a table, right? Perfect squares table right here. I want you to memorize 1 square, 2 square, 3 square, all the way to 20 square, those special numbers. So our special number here is 625. 625, we don't have it, right? 625, but we can try to use the big L technique to analyze it. Since 625 has 5 as the last digit, is divisible by 5. All those things we have already learned. Divided 625 by 5, we have this is 1, this is 2, this is 5. And 125 divided by 5, we have 25. 25 divided by 5, we have 5. So use the big L technique, we could analyze any whole number. So 625 is 5 times 5 times 5 times 5. And this together, we have this equals 25, this 25. So it's 25 square, right? So as you can see now, the binomial is a perfect square. The binomial is a difference of two squares. Difference of two squares. Thank you, Ashley. Oh, didn't I forgot to mark attendance? Yeah, let me do that now. 10 participants. We have Amanda, Ashley, Belle, Keelan. Okay. We have Ashley, Tevin. Do we have a white? Yes. Belle's here, Desiree's here, Kaylin's here, Jules here, Amanda's here, Belinda is here, Dakota is here. We don't have Sean. No. And Taylor is here. 11. Yeah, awesome. Let's continue. Do you guys see the structure of the binomial, it is a difference of two squares, right? The good news is the question reminds us use the formula, so we figured out. And then you're gonna write on your scratch paper, the first base is x squared, and second base is 25. So now we can factor this binomial as parentheses times parentheses. In the first parentheses, we have the first base plus second base. In the second parentheses, we have the first base minus second base. But not done yet, okay? We are not done yet. And then I'm going to write 25 as 5 squared. And you would see this binomial is a sum of two squares. Let me show the rule for sum of two squares we have learned. Remember this table? Sum of two squares is prime, right? Sum of two squares is prime. So x squared plus 25, x squared plus 25 is not factorable. So x squared plus 25 is not factorable. I'm going to write 25 squared back to 25. However, the yellow binomial here is a difference of two squares. Difference of two squares can be factored as the multiplication of two binomials, and the two binomials are conjugate of each other, right? So we can use the formula one more time, twice, and factor x squared minus 5 squared as x plus 5 times x minus 5. Do you see the yellow part? And now our factorization is complete. This one is challenging because we use the formula twice. And please let me know, is that clear? You would have to practice in order to feel comfortable with this type of problem. It's actually a difference of fourth power. And how do we use this formula twice? Use this formula twice to get this binomial factored. Do you have any questions? Guys, do you have any questions? So if I type, I'm going to type 3 parentheses. In the first parentheses, I have x squared plus 25. In the second parentheses, I'm going to have x plus 5. In the third parenthesis, we're going to have x minus 5. Like that. You see that? And let me see if you have any questions. Oh, okay, thank you for responding. All right, next question. Factor by using is very little, but we need to get used to it because if you go to when you go to testing center with the lockdown browser, you cannot zoom in or zoom out. You would have to get used to looking at this tiny print. So this one we are factoring. Read the instruction. Factor by using formula, okay? Factoring by using formula. We only learned 3 formulas, so not too much to ask. And this is the first formula. A squared minus b squared equals a minus b times a plus b. If the polynomial that is given is a trinomial, that means you are going to use either this one or this formula, one of the two. Let's see our trinomial. Since the middle term is positive, very likely we are using this formula. And the first term, 25x squared, is 5x to the power of 2. Okay, 25x squared, 25 is 5 times 5. X squared is x times x. I put this 5x together and those 5x together, and I have 5x to the power of 2. And then plus 9dx, and 81 is 9 squared. So the first base is 5x, and the second base is 9. If I multiply the two bases together and double it, let's see what we have. 2 times 5 is 10, 10 times 9 is 90, 90x. And exactly the same with the middle term. So yes, this is a quadratic trinomial. This is a perfect square trinomial. Perfect square trinomial. And also we know it's because the question requires us to use the formula. It has to be a perfect square trinomial in order for us to be able to use the formula. So by the formula, we are going to factor this trinomial as a square of binomial sum. The sum of the first base and the second base. So the square of 5x plus 9. Questions? I might go a little bit fast because we are recording. You can always watch the recording. If anything is not clear, you can like watch it again. Because I want to have more time to cover more questions. So I count 3. If nobody say anything, I'm gonna repeat, continue. Let me type the answer here. Also be very careful with typing. All that matters is what you type in a cell. In the parentheses, we have 5x plus 9. And that's it. Next problem, factor by any method. Okay. If you are given a trinomial and it says factor by any method, you know what? That means you are not using the formula, okay? That means you are not using the formula. While it is a quadratic trinomial and GCF is 1, just take a glance, you know GCF is 1. And the leading coefficient is different from 1. So what's the method we are going to apply? What method we apply to factor a quadratic trinomial with leading coefficient different from 1? Slide by slide. So the slide is to multiply with the constant and create a new polynomial. The new polynomial is going to be x squared plus 11x minus 26. And then we are going to shortcut. We actually have a shortcut here. To shortcut, we need to find the two integers, multiply to negative 26, add up to 11. If we are looking for two numbers, the two numbers multiply to negative. One is a positive, the other is negative. And the addition is a positive, that means the positive number has a bigger absolute value. Okay, this is the case number 3. Two integers multiply to negative, add up to positive. Then the two integers have opposite sign. The positive number has a bigger absolute value. So let's factor 26. 1 times 26, 2 times 13, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 no, 10 no, 11 no, 12 no. So only 2 ways to factor it. And the positive number has big absolute value. So I put a positive sign on top of the second column and negative sign here. So do those two numbers add up to 11? Negative 1, positive 26 do not add up to 11. And what about negative 2 and a positive 13? Negative 2 and a positive 13 add up to 11. Yeah. So the two integers are negative 2, positive 13. Okay. So the trinomial is factored as x minus 2 times x plus 13. Always double check, doesn't hurt. Negative 2 and 13 multiplied to negative 26 add up to 11. Okay. And then divide the two red number by the original leading coefficient, in this case 26. And then we simplify. 2 over 26 can be simplified as 1 over 13. 13 over 26 can be simplified as 1 over 2. And then, since we still have denominator, we are going to slide it again. The final answer is 13x minus 1 times 2x plus 1. 13x minus 1, 2x plus 1. Done. Yeah, that's the answer. Well, those are not very easy. I would say you really have to know the method in order to get it done correctly. 13x minus 1, 2x plus 1. (13x minus 1) 2x plus 1. Double check. Any questions? Next, remove the GCF. Check your answers by multiplication. So you really have to read the instruction. It says remove the GCF. Remove the GCF. So that means factor out the GCF. Okay, it means factor out the GCF. Or remove the GCF outside the parentheses. Check your answer by multiplication. Okay, factor completely. All right. Do we have a GCF to remove? No, we actually don't. Okay, we actually do not have GCF to remove. GCF of the 4 terms is 1. How many terms in this polynomial? 1 term, 2 terms, 3 terms, 4 terms. Do you guys remember what method we're going to apply to factor a polynomial containing 4 terms? Cut it in the middle, right? Okay, so we're going to have the first 2 a group, and second 2 terms, the last 2 terms a group. So 2 groups. And then we're going to draw 2 boxes. The first box, we're going to have the first group, 5xy squared minus 3ay. And second box, we're going to have 2xy minus 2y. And those 2 terms, let's find the GCF in the first box. GCF is y. And then we factor y out. We have 5xy minus 3a here. And in the second box, GCF of 2xy minus 2y is 2y. Okay, I got it. I might say that it always works when you group the first two and the last two, but this one is the exception. We're supposed to group the first and the third, and then the second with the fourth. Has to be like that. Okay, so in the first group, we have 5xy squared plus 2xy. Second group, we have negative 3ay minus 2y. So from the first group, we have x is common, y is common. Factor that out, we have 5y plus 2. Hold on. Oh my gosh. GCF is y. I apologize. My excuse is I'm sleep deprived. I apologize. So the question specifically clearly tells us to remove the GCF. I should have been more careful. I apologize. GCF is y. Let's factor y out. So 5xy here minus 3a plus 2x minus 2. Why do we have an a here? And that's it. And that's it. Yeah, I make it too complicated, but actually this is pretty simple. All we need to do is to factor y out times parentheses. In the parentheses, we have 5xy minus, because it has four terms, kind of like confusing, minus 3a plus 2x plus 2x minus 2 minus 2. 5xy minus 3a plus 2x minus 2. Okay, so that's it. So I think the instruction actually gives us the hint and what should we exactly do. Remove the GCF, and that probably that is that. Because inside the parentheses, that polynomial with four terms is not factorable. Is not factorable. And that's it. Okay, so let's move to the next question. Let me copy paste the whole thing. I can see better. Let's read the instruction. Complete the following sentence. A polynomial that cannot be factored by the methods of this chapter is called, okay, this is actually a simple question. Prime or not factorable. Prime. Next question. Copy paste. Factor by using the perfect square trinomial formula. Okay, so if they specifically said use the formula, what you would do is to write down the two formulas. Since the middle term is positive, we're going to use the first formula. So this quadratic trinomial, 100x squared is 10x to the power 2, and 1 is 1 squared. In the middle, we have twice of the multiplication of the two bases. So the first base is 10x, and second base is 1. So we can factor this trinomial as square of a binomial sum, first base plus second base. Question? The instruction make it easier, guys. Please make sure you read it. Let me enter the answer. I enter parentheses first, and raise to the power of 2. And inside the parentheses, I have the first base 10x plus second base 1. All right. Next, you copy paste. You know, if I needed to go to testing center and take the exam, I'm gonna bring a amplifier with me, like something like that. Cause I would use that to look at the screen and make sure I'm not making mistake. Let's read this instruction. Factor by grouping. Oh, okay. You see the pattern. If it doesn't say factoring by grouping, then don't use it. If it says specifically factoring by grouping, then that's going to be factoring by grouping, all right? And this is the factoring by grouping. So cut in the middle. The first two terms, 2ax plus bx. Second, the last two terms, negative 4a minus 2b. Well, I did not say that wrong. You don't have to worry about how to group. The first two, last two always work. 2ax plus bx. Any exams, when you take exams, you would have to apply certain strategies. Maybe some student, like you study the same hard, but someone just perform better in the exam because firstly, they are not nervous or they don't have the anxiety. Secondly, they have a certain strategies to can make their job easier. So my point here is read the instruction. The question specifically tells us factoring by grouping. So we're going to do that. And the two terms has GCF x factored out. We have 2a plus b in the parentheses. And second group, negative 4a minus 2b. We want to factor something out in order to have 2a plus b inside the parentheses. And that has to be negative 2. Okay? Only when we factor negative 2 out, inside the parentheses, we have 2a plus b. If you are not sure, double check by reversing. X times 2a, 2ax, x times b, bx. Negative 2 times 2a, negative 4a, negative 2 times b, negative 2b. And then we put it back here. And we have x times 2a plus b and minus 2 times 2a plus b. And now the two groups have a common binomial factor. We are able to factor the common binomial factor 2a plus b. From the first group, we have x left. From the second group, we have a negative 2 left. And this is the final answer. You need to remember that 2a plus b, x minus 2. 2a plus b, x minus 2. A plus b, x minus 2. 2a plus b x minus 2. All right. Next, as I said, I'm recording. Just double check. Yeah, I'm recording. So go back to watch the recording once it's loaded. Sometimes it takes like a half an hour. Where do we access the recording? That's a very good question. Let me show you right now. So you go to Blackboard and courses, and this semester is fall 20. Sorry, hold on. Spring. You cannot imagine how sleepy I am. I'm so sorry. Spring 2024, and then go to our class here, and then virtual classroom. And do you see the sandwich? Do you see the sandwich? Click that. You see the recordings? Click that, and you look all the recordings. Our class start from when? Recent recordings. I believe there's another page. If you change this to recording in a range, from our class start from February, let's say February 1st, and to today. And now you can see we have 2 pages. If you move to the second page, in the first class, we start from February 12th, 14, and then February 19. I think every time I remember to recording. And so this is very recently. Okay, so if you don't see all of them, go to right here, check recordings in a range, and change the time that cover this semester, and you will see all the recordings. Okay. The videos on the MyLab help too. Oh yeah, sure. Before every chapter. I see. Okay. Where were we? So this is gonna be the question number 8. I'm saying if you want to watch the class recording, that's where you find it. Okay. Sorry to interrupt. Okay, no problem. Factor by using perfect square trinomial formula. When you see perfect square trinomial formula, it refers to either this one or this one. And we need to find the 2 bases. 64 is 8. 64x squared is 8x to the power of 2. 81 is 9 squared. So the first base is 8x. Second base is 9. The middle term has to be twice of the first base times the second base. Just to double check, and it is. 2 times 9 is 18. 18 times 8, 144. So we are going to write this trinomial as a square of a binomial sum. First base plus second base. So it's 8x plus 9 to the power of 2. Ax plus 9. Very good. Next. Using the factoring method, solve for the roots of the quadratic equation. Be sure to place the equation in standard form before factoring. Check your answer. Okay, so this one, if we follow the instruction, firstly, we would minus 36 from each side and keep the right side of the equation as 0. So we have 4x squared minus 36. And then I'm going to divide everything by 4 to make the equation look simpler. And we have x squared minus 9 equals 0. And the left-hand side, we have a binomial. And that binomial actually is a difference of two squares. So we are able to factor x squared minus 9, which is x squared minus 3 squared, as x minus 3 times x plus 3. Right? Remember, if the equation is in this format, we just need to take the opposite of those two numbers and we would have the solutions. So the opposite of this yellow, red and yellow, positive 3. And the solution and the opposite of this number is negative 3. So the two solutions are 3 and negative 3. Use a comma to separate answers. So you're going to enter 3, comma, negative 3. 3 comma negative 3. Next. Factor by first looking for a GCF. Let's do that. The instruction gives you the kind of like a guide. Firstly, factor out GCF, right? Okay. And what's the GCF? 108 and 3. Does the 3 go into 108 completely? I think so, because 108, the 3 digits, 1 plus 0 plus 8 is 9. 9 is divisible by 3, so 108 is also divisible by 3. You have a calculator, so I believe you can figure it out. And if we divide 108 by 3, we have 36. So we factor 3 out because 3 is the GCF. In the parentheses, we're going to have 36 x squared minus y squared. But we're not done yet. If you stop here, then you're going to lose a point. This is not final answer. And look at whatever inside the parentheses. Whatever inside the parentheses is a difference of two squares. Okay? 36x squared, that is square of 6x. Y squared, that is y squared. So the first base is 6x. The second base is y. So continue. Don't forget that we have 3 in front. And this difference of two squares can be factored as base 1 minus base 2 times base 1 plus base 2. And that's the final answer. We still use the formula, but before applying the formula, we need to factor out the GCF 3. Let me enter the answer. Factor 3 out, and we have parentheses times parentheses. Inside the first parentheses, we have 6x plus y, and this is 6x minus y. The order of those two parentheses doesn't matter, by the way. 6x minus y. 6x plus y, 6x minus y. And that's it. If you want to double check your answer, you can multiply the parentheses and to see if you go back the original polynomial. Double check. 6x minus y, 6x plus y. Okay, correct. Next. Factor. It doesn't say anything, right? Then how do we factor this one? If it doesn't say the formula, then you do not use formula, okay? This one, find the GCF first. GCF is x. So let's factor x out. Inside the parentheses, we have 15x squared minus 11x plus 2. And inside the parentheses, this is a quadratic trinomial. 15x squared minus 11x plus 2 is a quadratic trinomial with the leading coefficient different from 1. So we want to slide, divide, slide. Create a new trinomial by sliding the leading coefficient and multiply with the constant. And then we shortcut. We need to find the two integers. Multiply to 30, add up to negative 11. You know what? I think they are 95, 96. Okay? Has to be 95, 96. You can try, use my procedure. What happened? 30 is 1 times 30, 2 times 15, 3, 10. 4 doesn't work. 5, 6. And both of the two numbers has to be negative. And only 95, 96 add up to 11. And then divide. Divide the two red numbers by the original leading coefficient. And then simplify. Five over 15, 1/3. 6 over 15, 2/5. All right. And then we can slide it back. We only slide it back when we have denominators. And the final answer is going to be this part. This part is going to be 3x minus 1 times 5x minus 2. 3x minus 1, 5x minus 2. So put it back. Don't forget that we have x in front. So x times 3x minus 1, 5x minus 2. And this is the final answer. Let me tell you, this is challenging, okay? I'm not saying this is easy. This is not easy. That means we would have to practice a lot. Let me enter the answer. Don't forget we have x in front. 3x minus 1, what is that? 5x minus 2. Minus 2. All right? 3x minus 1, 5x minus 2. Next. Factor. Be sure to look for common factors first. Well, there's no common factor. GCF is 1. This is even. This is not even. So this one doesn't have x. So GCF is 1. And how do we factor this quadratic trinomial with leading coefficient different from 1? Slide, divide, slide. Okay. So we're going to create a new trinomial, x squared plus 12x, 4 times 9, 36. And then shortcut. We are looking for two numbers. They multiply to 36, add up to 12. It's gonna be, let's see. The two numbers must be both positive. We can do 1 times 36, both of them have positive. 2 times 18, 3 times 12, 4 times 9, 6 times 6. Yeah, 6. This actually is a perfect square trinomial. Yeah, actually it is. And then we divide. It didn't say the formula, right? And divided the two numbers by leading coefficient 4. And we have x plus 3 halves times x plus 3 halves. And slide it back. We have 2x plus 3 to the power 2. Yeah, this one actually is a perfect square trinomial. We could totally use the formulas. Oh, this actually is a perfect square trinomial, guys. So, well, sometimes the question tells you to use the formula, sometimes didn't tell you. Well, even we do not use the formula, we use the slide divided slide. It worked, right? It's 6 times 6. Positive 6, positive 6. So it's square of 2x plus 3. Square of 2x plus 3. Next, copy paste, and then I can read the question. Using the factoring method, solve for the roots of the quadratic equation. Be sure to place the equation in standard form before factoring. Yeah, those are good reminder. Good reminder. Okay, so GCF, there's no GCF. And we are going to apply slide divide method. Okay. 4x squared minus 17x plus 15 equals 0. The left side is already in the standard form. Right side is 0. Slide. We have x squared minus 17x plus 15 times 4, 60. Shortcut. We are looking for two numbers. Multiply to 60. Add up to negative 17. The two numbers must be both negative. So you want to look at the 4 cases, the 4 conclusions on the note. If two integers multiply to positive, add up to negative, then the two integers must be both negative. And then we factor 60. 1 times 60, 2 times 30, 3 times 20. That one is very confusing. 4 times 15, 5 times 12. Yeah. We don't have to continue, you know. We could continue 6 times 10. Yeah, but we already found our pair. 95, negative 12. Negative 5 times 95 and negative 12. Make sure double check your answer. 95 times negative 12 equals 60. Negative 5, negative 12 add up to negative 17. And then we divide both the two numbers by the original leading coefficient 4. And we are going to simplify the fraction here. Negative 5/4. This is negative 3. That's it. We're not done yet. I mean, slight divide. We are done with those two steps. Slight divide. And what are the solutions? The solutions are the opposite of this number and opposite of this number. So you're gonna enter 5/4, comma 3. 5/4, comma 3. Type an integer or a simplified fraction. By the way, guys, I know 5/4 equals 1.2. Please do not enter 1.2 because the instruction specifically tells us type an integer or a simplified fraction. Use a comma to separate answers as needed. You don't want to lose a point for that because of that. So what is the answer again? 5/4. 5/4. This is fraction. Oops. Comma 3. Be very careful. I need to double check, did I enter comma or dot? Let me just do it again. Comma. If you enter dot there, it's also treated as wrong. Alrighty, next. Just simply factoring. And you know what? This one doesn't say use a formula. It does not say using formula, but it's actually a perfect square trinomial. Perfect square trinomial. How do we know that? Because the last term is a perfect square. That's a strong sign. Is very likely this is a perfect square trinomial. So let's see if it is. And the first term is x squared, last term is 7 squared, and in the middle we happen to have twice of the multiplication of the two bases. 2 times 7 is 14. Yes, it is a perfect square trinomial. The first base is x. The second base is 7. So we can write this trinomial as a square of a binomial sum x plus 7. X plus 7 to the power 2. Parentheses. No, it's 2. Second power, x plus 7. Do you see something wrong here? I think I accidentally entered a slash, so be very, very careful. Be very, very careful. X plus 7 to the power 2. Okay, next. This one, so many formulas. I think this one, this one is not. This one is not a perfect square trinomial. How do I know? Let me explain. How do I know? In order to be a perfect square trinomial, this term is a perfect square, and this term also has to be a perfect square. But this one is not perfect square, right? And also, you know what? What's the GCF? The three numbers are so big. When the numbers are so big, you would really definitely have to consider GCF. 18, 51, 36. The GCF is 3. So let's factor 3 out. In the parentheses, we have 6x squared minus 17x plus 12. Let me double check. 3 times 6, 18. 3 times 17, 51. 3 times 12 is 36. And what about this trinomial? And let's put it here and work on it. Slide. Twelve times 6. Shortcut. When you are very familiar with those numbers, you can get it done very fast. Let me explain why do we have that. So shortcut method, we need to find the two integers, multiply to 72, add up to negative 17. They have to be both negative in order for this to happen. So which two negative number? We try 72. We have 1 times 72, 2 times 36, 3 times 24, 4 times, you use your calculator, 18. Yeah. 5 doesn't work. 6 times 12. 7 doesn't work. 8 times 9. And they have to be both negative. And this one works because only negative 8, negative 9 add up to negative 17. And then divide the two-root number by the original leading coefficient. And simplify. X minus 8 over 6 is 4/3. 9 over 6 is 3/2. And then slide it back. And we have this one inside the parentheses. We have 3x minus 4. 3x minus 4 and 2x minus 3. And this is the final answer. Don't forget we have 3 in front. 3x minus 4, 2x minus 3. So please practice. I would have said from the review, those questions are not easy, let me tell you. 3 times, you really have to really skillful, like grasp this question very well. We have 3x minus 4, 3x minus 4. Did I enter plus 4? Minus 4, minus 4. And this here is 2x minus 3. 2x minus 3. All right, next. Factor by first looking for a GCF. Let me copy paste. Okay, what's the GCF? We see 32, 48, and 18. GCF is 2. Factor 2 out. Inside the parentheses, we have 16z squared plus 24z plus 9. Double check. 32z squared, 48z, and 18. Okay. And inside the parentheses, we are going to see if we could use this formula. Because the first term is a perfect square, is 4z to the power 2. The last term is a perfect square, it is 3 squared. So the first base is 4z, second base is 3. And if we multiply the two bases together and double it, let me see what do I have. 2 times 4 is 8, 8 times 3 is 24z. So yes, this is a perfect square trinomial. So the answer is going to be, this part is going to be square of the first base plus the second base. And put it back. The answer is going to be 2. Don't forget we have 2. 2 times 4z plus 3 to the power of 2. 2 times 4z plus 3 to the power of 2. 2 times 4z plus 3. Double check. I would look at whatever I enter in the cell and then look at my scratch paper to see if they are the same. If I entered what I wanted to enter. All right, next. This is a multiple choice question. Factor if possible. Be sure to factor completely. Always factor out the GCF first, if one exists. That's a good reminder. Because the trinomial, this trinomial, so busy, looks very busy, right? That is a sign. It probably has GCF different from 1. So look at the numerical part, 6, 36, 54, GCF is 6. Why? Because 6 is a factor of 36. 6 is also a factor of 54. So that's the first special case we have. We're going to factor 6 out. And x is also common. Y cube also common. So the GCF is 6x y cube. Factored out, inside the parentheses, we have x squared minus 6x plus 9. Double check. 6xy cubed times x squared is 6x cubed y cubed. 6xy cubed times negative 6x is negative 36 x squared y cubed. 6xy cubed times 9, 54xy cubed. So that's correct. Our factorization, the GCF factored out whatever inside the leftover inside the parentheses is also correct. But we're not done yet, okay? This is factorable. Let's factor it here. And this is again a perfect square trinomial. Equals a minus b to the power 2. How do we know it's a perfect square trinomial? First term is x squared, last term is 3 squared. In the middle, we have a negative twice of the multiplication of two bases. So the answer is going to be square of binomial difference. First base is x. Second base is 3. So x minus 3 to the power 2. Don't forget, we have a 6x y cube in front. And then we have x minus 3 to the power 2. These are challenging. 6xy cubed times x minus 3 to the power 2. 6xy cubed. 6xy cubed and then times x minus 3 to the power of 2. 6xy cubed times x minus 3 to the power of 2. Okay. All right, next. Even those questions are like not very straightforward, but each component of the solution, we cover them in the class. For example, I said whenever we need to factor a polynomial, observe and identify the GCF of all the terms, right? So you have to factor out GCF. And we also cover the special factoring. And let's see this question. Factoring by grouping. Okay, cut in the middle. Cut. And then the first two, and the last two, draw two boxes. First two terms, put it here, first group, second group. And what's the GCF of AB and 93A? A. Factored out, we have B minus 3. Double check if you are not sure, okay? A times B, AB, A times 93, 93A. And this one, we want to have a B minus 3 in the parentheses. So we factor 4 out. 4 times B is 4B, 4 times 93, that is 12. And then we have the first group, A times B minus 3, plus second group, 4 times B minus 3. They have the same binomial, common binomial factor. So we're going to factor B minus 3. From the first group, we have A. From the second group, we have 4. There we go. This question is not challenging, okay? This one is the difficulty level. The level of difficulty is similar with the examples we covered in the class. Let me enter the answers. B minus 3, A plus 4. B minus 3, A plus 4. There's no other way to improve your mathematics. The only way is to practice, practice the same question many times if the question is a good one. For example, the questions we cover in the class on my worksheet, class worksheet. And you understand that, you grasp the tools that you need, and then work on the review, quizzes, and Pearson. And some questions actually not very straightforward. Difficulty level is a little bit high, but the component you need to use, the tools you need to use to solve the problem is the same with we have learned in the class. And that's the factoring by grouping. Let's move to next question. Using the factoring method, solve for the roots of the quadratic equation. Be sure to place the equation in standard form before factoring. Check your answers. Okay. Standard form. That's a good reminder, because this equation is not in the standard form yet. How do we put it in a standard form? We could move negative 43x over to the left, or you can plus 43x here. Either way, our goal is to make the right-hand side be 0. And left-hand side is 25x squared, plus 40x plus 16 equals 0. Let me rewrite it here. So I have 25x squared plus 40x plus 16 equals 0. You know, there's a sign that this might be a quadratic trinomial. Sorry, perfect square trinomial. Perfect square trinomial. We have used this formula so many times today, right? How do we know? Strong sign. 25, 5 squared. X squared, 16, 4 squared. So very likely, but let's double check. So the first term is the square of 5x. The last term is the square of 4. So the first base is 5x. Second base is 4. And if we multiply the two bases together and double it, we have 40x. So yes, it is a perfect square trinomial. So we are able to write the left-hand side as the square of binomial sum. First base plus the second base. Okay? 5x plus 4 to the power of 2 equals 0. So if we have a perfect square equals 0, the base has to be 0. Think about if the base is not 0, the base to the power of second, the base square is not possible to be 0. So the base has to be 0. And then we're going to solve this equation. Move 4 over, and then divide by 5. X equals negative 4/5. So x equals negative 4/5. There's only one solution, by the way. There's only one solution. Let me double check this question. 25x squared plus 40x plus 16. 5x plus 4 to the power 2. Negative 4 over 5. Yeah, that's correct. Negative 4 over 5. Negative 4 over 5. Next. Using the factoring method, solving for roots of the quadratic equation, be sure to place the equation in standard form before factoring. Check your answers. So we have x squared plus 5x plus 4 equals 0. It is already in the standard form. Right side equals 0. Left side is a quadratic trinomial with leading coefficient 1. So we could factor the trinomial by using shortcut method. We need to find the two numbers, multiply to 4, add up to 5. They have to be both positive. Okay? Do you agree? 4 and 1, multiply to 4, add up to 5. So the solutions are going to be the opposites of those two numbers. The opposite of 1 is negative 1. Opposite of 4 is negative 4. So I'm going to enter negative 1, comma, negative 4. 1, comma, -4. 91, comma 94. Okay. Next. Factor by using the difference of two squares formula. This is the difference of two squares formula. Do we have some Jill, do you have a question? It shows you raise the hand. Well, it was just accident. Jill, do you have a question? Okay. Okay. All right, the formula is a squared minus b squared equals a minus b times a plus b, or a plus b times a minus b, really doesn't matter. And this binomial is a difference of two squares because 36y squared is 6 times 6 times y, and is 6y times 6y. It gives us square of 6y. And 1 is 1 squared. So the first base is 1. Second base is 6y. So we are able to factor this binomial as first base plus second base times first base minus second base. Be very careful with the order of the two bases. One of the parentheses has to contain the first base minus second base. One plus 6y, 1 minus 6y. 1 plus 6y, 1 minus 6y. Yep. Next. This is a multiple choice question. Factor if possible. Check your answer by multiplying. This polynomial has 4 terms. This time let me observe to see if the grouping method works. Yes. X plus 2y. It works, the grouping method works, but it's challenging. It's challenging because A minus 4c. Actually, it works as well. So cut in the middle. It's factoring by grouping. Cut in the middle, the first two terms, ax minus 4cx. And the last two terms, well, this line actually blocking, I couldn't see is positive. Plus, okay. Is plus 2ay minus acy. 2 boxes. First box, first group, ax minus 4cy. Second box, the second group, 2ay minus 8cy. Ax minus 4cy, 2ay minus 8cy. So this one, GCF is going to be F. Oh, I copied it wrong. This is a 4cx. 4cx. Double check ax minus 4cx. This is 2ay minus 8cy. From these two terms, we factor x out. We have a minus 4c. You can double check by reversing, right? And this group, we factor 2y out. We wanted to have a minus 4c. Let's see if it works. 2y times a, 2ay. 2y times negative 4c, negative acy. So it works. So the first group is x times a minus 4c, plus second group is 2y times a minus 4c. And the two groups have the same common binomial factor. We factored out a minus 4c. And left over from the first group plus left over from the second group. And we're done. A minus 4c times x plus 2y. A minus 4c times a minus 4c, x plus 2y, x plus 2y. A minus 4c, x plus 2y. Okay. Next. Oops. What is it? Copy. Paste. Factor if possible. Check your answer by multiplying. This is a difference of two squares. It's a binomial. It's a binomial, everyone. If it's a binomial, very likely we use this formula. And also strong sign, 16 4 squared, 9 3 squared, right? Here 16x squared, 16 is 4 squared, 4 times 4 times x, and that is 4x times 4x. It is square of 4x. Similarly, 9y squared, 9 is 3 times 3, y squared is y times y. So 3y times 3y, we have square of 3y. So this binomial is square minus a square. First square has base 4x. Second square has base 3y. So by the formula, the answer is going to be 4x minus 3y times 4x plus 3y. Four x minus 3y times 4x plus 3y. 4x minus 3y, 4x plus 3y. Okay. And this one, similar with our examples. Next in the class. Using the factoring method, solve for the roots. Be sure to place the equation in standard form before factoring. Solving equation. X squared minus 6x minus 27 equals 0. Shortcut. We are looking for two integers. Multiply to negative 27, add up to negative 6. So the two integers have to have an opposite sign. And the negative number has a bigger absolute value. Positive number has a smaller absolute value. This should be case number 4. If two integers multiply to negative, add up to negative, then the two integers must have an opposite sign, and the negative number has a big absolute value. And so let's see which two numbers. If we factor 27, 1 times 27, 3 times 9, 5 doesn't work, 7 doesn't work, and that's it. Only two ways to factor it. And this is gonna be negative, this is gonna be positive. And it doesn't work because they do not add up to negative 6. This one works. Positive 3 and negative 9. Positive 3, negative 9, multiply to negative 27, add up to negative 6. So we have plus 3 minus 9. What's the opposite of this number? What's the opposite of this number? And they are the solutions. And you know you have a calculator. If you have time, you should, if you have a proposed solution, you should plug it in to see if it satisfies the equation. Negative 3, 9. Negative 3, 9. Be careful, don't enter a dot. Sometimes that's a mistake I sometimes make. Oops, you see I entered a J. Negative 3, 9. Negative 3, 9. Okay. Did I enter 9? Yeah, negative 3, 9. Don't forget to bring your glasses with you when you take the exam. Next question, factor by taking out the GCF. Let's see. The three coefficients are 25, 5, 20. GCF is 5 because 5 is a factor of 25, also a factor of 20. So GCF is 5. Factor 5 out. Let's see what do we have inside the parentheses. It's going to be 5x squared minus x minus 4. If you are not sure, double check. 5 times 5x squared, 25x squared. 5 times negative x, negative 5x. 5 times negative 4, negative 20. That's correct. And let's see this trinomial. 5x squared minus x minus 4. Slide, divide, slide. And we have x squared minus x minus 20. Shortcut. Which two numbers multiply to negative 20 add up to negative 1? Negative 5, positive 4. Multiply to negative 20 add up to negative 1. Yeah, how do we know? Because when we look for two integers multiply to negative, add up to positive, add up to negative, then they must have negative opposite sign, and negative number has big absolute value. And then we factor 20. We can do 1 times 20. We can do 2 times 10. We can do 4 times 5. And we place a negative sign here, positive sign here. This one doesn't work. This one doesn't work. And this one works. Positive 4, negative 5. And then divide the two red numbers by the original leading coefficient, which is 5, and then simplify x minus 1, x plus 4 over 5, and slide back because we have a 5 here, slide back. Then we have x minus 1 times 5x plus 4. Put it back. The final answer is going to be, don't forget the 5 here, 5 times x minus 1 times 5x plus 4. This x minus 1, 5x plus 4. Five times x minus 1 and here is 5x plus 4. 5x plus 4. Take your time to enter the answer and double check your entry is the same with whatever on your scratch paper that you wanna enter. Okay. Next. Oh, the graph there. Maybe it's bigger. Shaded area. Okay, we are looking for the shaded area, right? This is an application problem. We are looking for the area of the shaded region. Find a polynomial in factored form of the, we also need to read this part. Water problem, we need to read the words. It's not possible to get it right if we don't read the words. Find a polynomial in factored form of the shaded area. Both figures are rectangles with dimensions as labeled. Okay, so the area of the shaded region is going to be the area of the bigger rectangle minus the area of the smaller rectangle. The big rectangle and a small rectangle, shaded region. Let's see their area. The area of the big rectangle. Area of a rectangle is base times height, or length times width. 9 times 7. Because this is 9, this is 7, right? The bigger rectangle has area 63. I'm not sure the unit, but seems it doesn't matter. That's the difference between mathematics and physics. In physics, unit make a lot of a difference. In mathematics, sometimes we just ignore that. Like in this case, we didn't have inch or inch or meter. Okay, so the bigger rectangle has area 63. Let's see the smaller rectangle is going to be the length times width. It is x plus 2 times x. Or you can write width times length. It really doesn't matter. Switch the order because of the commutative property. 2 times 3 is 6. 3 times 2 also 6. So x times x plus 2. And what's the area of the shaded region? The area of the shaded region is the bigger rectangle area minus the smaller rectangle area. This is the region, okay? And we need to find a polynomial in factored form. That's very important. In factored form. So we have to factor this polynomial. Let's do that. 63, firstly, simplify by removing this parentheses, applying distributive property. Negative x times x, negative x squared. Negative x times 2, negative 2x. So we are able to write this trinomial in a standard form. We want to write the trinomial in a standard form. So negative x squared minus 2x plus 63. That's the trinomial in the standard form. Leading coefficient is negative 1. Remember our class worksheet? There was one question I demonstrate. I said the reason we have this question because I want to show you how do we factor polynomial, quadratic trinomial if leading coefficient negative 1. If the leading coefficient is negative 1, we factor the negative sign out. And inside the parentheses, we're going to have x squared plus 2x minus 63. And then we are going to factor, we are going to factor the trinomial here. I'm going to do it here. X squared plus 2x minus 63. Shortcut method. We need two integers multiply to negative 63, add up to positive 2. Then the two integers must have opposite sign. And the positive number has bigger absolute value. The negative number has a smaller absolute value. So let's try 63 is 1 times 63. 2 doesn't work. 3 times 21. 4 doesn't work. All the even numbers don't work because 63 is odd. 5 doesn't work. 7 times 9. So the positive number has bigger absolute value. Negative number has a smaller absolute value. So we try this. No, no, yes. The two numbers are negative 7, positive 9. Negative 7, positive 9 multiply to negative 63, add up to positive 2. Let's put it back. The trinomial can be factored as x minus 7 times x plus 9. And this is the answer. This is the answer. Let me double check. Find a polynomial in factored form of the shaded area. Both figures are rectangles with dimensions as labeled. And this is the bigger area, 63, and this is smaller. Take the difference and then factor. Put it in the standard form. Factor out negative 1. And then factor this trinomial by using shortcut. Okay, this is the answer. Negative x minus 7x plus 9. Oops. Negative x minus 7x plus 9. X minus 7 x plus 9. Negative x minus 7x plus 9. Okay. Next up, how many minutes? We have 6 minutes. We are good for today. Factor if possible. Check your answer by multiplying. Okay, this is about shortcut because this is a quadratic trinomial with leading coefficient 1. B is 17, C is 72. By the shortcut method, we need to find the two integers, multiply to C, add up to 17. The two integers must be both positive. So let's figure out which two numbers. Two times 36, 3 times 24, 4 times 18, 6 times 12, 7 doesn't work, 8 times 9. There we go. 8 and 9, right? 8 and 9 multiply to 72, add up to 17. So this is a very simple problem. The answer is x plus 8, x plus 9. X plus 8, x plus 9. This one is very simple. I wish all the questions like this. Next. Oops. So many words. We have 4 minutes. How about let's stop here. And let me close this directly, close it. Then next time we still have the access to all the questions. All right, so let me close here. We have 3 minutes. If you have any questions, any concerns, I can address your concern before we say goodnight. Did I lose one student? I lost 2 actually. Okay. Thank you, Jill. You have a good night. I'll see you guys on Monday. All right. Have a good weekend. Feel free to email me if you have anything.